Alright, so today, super easy day again. Today we're doing inverse axioms, and so the main idea is goes like this. Newton said a long time ago, for every action there's a reaction, right? For every arrow that goes up, there's an arrow that goes down. For every arrow that goes right, there's an arrow that goes left. Imagine if this was the case for a lot of things in life. If you have Batman, for every Batman there is the Joker, right? This is the anti-Batman. For every Superman there's some kryptonite. I don't know how to spell kryptonite, but something like that. So for every yin there's a yang, right? You guys seen this super famous symbol of Taoism? So that's the idea with inverses. The trouble is that there are many types of inverses, and so we have to be just a little bit careful when we talk about inverses. And it goes like this. The careful explanation should go like this. There are many different things that we could mean when we say opposite. Opposite has to be really clarified. As an example, suppose I ask you, what is the opposite of 2? See, some people may say, well, it's -2. Some people may say, no, it's 1/2. Some people may say, no, this is the opposite of 2 because it's 2 backwards. Or maybe like this, 2 written from right to left. Or maybe the mirror image of 2. You see, when you really start talking about inverses or opposites, there are many different types that you could possibly associate. We're going to do it the professional way. And that is that whenever you say opposite, you say that's ambiguous. We say, what do you mean by opposite? What kind of opposite? And it's going to be tied to the binary operation that we're talking about. That's why we spent the first day just talking about binary operations. Remember? You remember we did these 4 binary operations, and we said that's what we do in this class, and we did the mixing recipe and whatnot. So, for example, let's go look here. So for addition, here's what we're going to mean by opposite. First of all, first step is you figure out what's the water element. You got water. What is the water element? For addition, remember that's what we did last lecture. I'll remind you in case you forgot. Let me take you back to memory lane to about 10 minutes ago when you did this. Last time we learned that we had a multiplicative water. This is the water element. Nothing happens. When you multiply A times 1, nothing happens. You get A. Both ways. 1 times A, nothing happens. You get A. That's the water element. The identity element for multiplication. Additive identity, when you add 0, nothing happens. 0, that way nothing happens. 0 is the water element, the identity. That's what we learned last time. So what we're learning this time is we first take look at the operation and figure out what's the water element, and then to figure out what it means to be opposites, we have to figure out what 2 things give you that guy. What 2 things give you water? So in the world of addition, for example, if I have 3, I need something that when I add it to 3, I get 0, I get water. So it would have to be -3. In fact, we've never talked about it formally here, but this is the definition. The definition of -3. It was born to be the killer of 3. It kills it and neutralizes it and gives you water. If 3 was the Batman, -3 is the Joker. They were made to complete each other, kill each other, and give you 0, give you the water element. Though the -3 is called the additive inverse of 3. So we don't just say inverse or opposite. We say what kind. We say additive inverse. This is the professional way to do it. You say, what kind of inverse are you talking about? Oh, additive. Oh, okay, that means that it gives you additive water when you put them together. They kill each other. So here, again, for multiplication, the first step is what's the water element? It's 1. Therefore, what are inverses? Well, they have to be things that give you 1. So, for example, 3 there's times what gives you 1? Well, there was, before, a long time ago, there was no number that did that, so we invented these numbers. They're called fractions. 1/3 was invented just for the reason, this whole purpose of being the killer of 3, to complete the 3. This is the Superman, this is the kryptonite, or if that's the Superman, that's the kryptonite. They're complementary pieces. They complete each other. This is the yin, this is the yang. They give you water, the identity. For mixing colors, imagine if you had red, well, you'd have to have something that gives you water, the water color, so it'd have to be some sort of anti-red, if there was such a thing. Okay, that's, I won't worry about these because they're not as important for now. I just want to focus on these ones. Actually, these three I like, but we're going to be using these a lot. Additive inverses, multiplicative inverses. That's the idea. They kill each other and give you water. Said more professionally, two things are inverses if their operation gives you the operation identity. Okay, the identity is the water element. Okay, so let's summarize this. Additive inverse, what it says that negative a plus a kill each other and give you 0. That's what it says. In fact, it defines what these negatives means. They are characterized by the fact that they kill the positive version of them and they give you 0. Okay? Negative a was born to be the killer of a. That's it. Let's go on. And how about what numbers does it apply to? Additive inverses applies to all the numbers from our class, all the variables from our class, all the terms from our class, all the symbols from our class. Okay, everything. Let's practice it a little bit. So, oh, by the way, you can also do it right the other way around. A plus a negative a was born to be the killer of a, so they give you the water, the neutral element, neutralized version. Let's practice it. So 4 plus negative 4, how much is that? Well, that would be 0. Why? By additive inverses. Negative 7 plus 7, how much is that? Well, that would be 0 by additive inverses. Negative x plus x, how much is that? Well, that would be 0. Why? By additive inverses. Negative 1/2 plus positive 1/2, what would that give you? 0. Why? By additive inverses. I could do all this all night long. It's so easy. Alright, that's how you practice it. Even 0. Negative 0 plus positive 0, how much is that? 0. Why? By additive inverses. I went there. Negative 0. Negative 1 plus 1, that's equal to 0. Why? By additive inverses. You can do this all day long. And you can get fancy with this. This alone might be enough for you to learn how to add positives and negative numbers together. This is a big mystery for a lot of people. But we already have enough power, enough tools to do that in the most elegant way, the most precise way possible. Let me just do something for fun here, because I can't help myself. Watch this. Suppose you wanted to add negative 10, oh no. Suppose you wanted to add, whoa, let's do a new page. Negative 10 plus 40, and how would you do that? Suppose that was given. And you may say, well, you know what? We had never done that in our class, and we took some amnesia pills at the beginning. We forgot everything, and we don't know how to do that. And whatever we know how to do, we don't just do it. We justify every step. Because justifying every step means I got swagger. I want to expand my mind. I want to be a chef. I want to understand things. So that I don't just write stuff there and hope it's right just because my teacher said so. No, I want to understand every single step. And we're at this point where we can do this. Now watch this. Negative 10 plus, instead of 40, I could write 10 plus 30. Why can I do that? Well, that's times table. We did, oh sorry, just kidding. Addition table. We did that at the very, very beginning. It was one of our first axioms, addition table. 10 plus 30 is 40. Why would I want to do that? Because I want to borrow 10 from here because that's the 10 killer. So who would kill the 10 killer? Well, the 10 would kill the 10 killer. Now I take these parentheses and I slide them over. Now I have negative 10 plus 10 plus 30. Who says I can take these parentheses and slide them over? Duh, that's the associative law of addition. So you practice that hundreds of times on the flashcards. But wait, there's more. What is 10 plus negative 10? That's where we're at today. These are born to be killers. The definition of negative 10 is the killer of 10. It's the anti-10. So That would give you 0, the water element for addition, and that of course would be additive inverses, the axiom that we're learning today. But wait, now how do I add 0 plus 30? Well, that's what we did last lecture. 0 does nothing to numbers when you add them, so of course that would be 30 by additive identity. Yippee-ki-yay. You see that? Perfection in reasoning. Perfection, beauty, and creativity in reasoning like you've never seen. That's what we sell. It's not the fast way to do it, but we don't care about the answer. We care about mojo and swagger and being the life of the party. This stuff will make you the life of the party. See, I already got people calling me, inviting me to parties. Alright, take a look. Pause here.